In this section, we're going to talk about theorems about the zeros of polynomial functions. Let's recall, if c is a zero of f of x, then x minus c is going to be a factor of f of x. So if we want to find a third degree polynomial that actually has the zeros of 2, 6, and negative 5, notice we have all zeros. We should have 3 because the degree is 3. To find this, all we need to do is come up with the factors and multiply. If 2 is a 0, then that came from the factor of x minus 2. If 6 is a 0, it came from the factor of x minus 6. And if negative 5 is a 0, that came from the factor of x minus negative 5, which is really x plus 5. Once we have these factors, then all we have to do is multiply out. Use your FOIL or distributive property. The first two will give us x squared minus 6x minus 2x plus 12, still times the x plus 5. Or cleaning that first part up, we'll have x squared minus 8x plus 12 times the x plus 5. At this point, we have a trinomial times a binomial, so everything in the first parentheses has to be multiplied by the second parentheses. We'll do the x squared times the x plus 5, the negative 8x times the x plus 5, and the positive 12 times the x plus 5. That's going to give us x cubed plus 5x squared minus 8x squared minus 40x plus 12x plus 60. One last time of cleaning up like terms will give us x cubed minus 3 of the x squareds minus 28 of the x's plus 60. This is the function that has the three zeros of 2, 6, and negative 5. Let's try that again, and this time let's say that we have the degree of 3, and our zeros are going to be 3i, negative 3i, and 7. If we're going to find the polynomial that has the degree of 3 with these answers, first thing we need to do is come up with our factors. Our function is going to have the factors of x minus 3i, x minus a negative 3i, which is actually x plus 3i, and x minus 7. Notice at this point we have some complex numbers in there. We'll multiply those two factors first for x squared plus 3ix minus 3ix minus 9i squared, still times the x minus 7. Note that your outer and inner terms will cancel out, which will leave us with x squared minus 9i squared times the x minus 7. Recall from our complex numbers the fact that I squared is actually equal to the real number of negative 1 and substitute that in. That will give us x squared minus 9 times negative 1, which is the same thing as x squared plus 9. We still have to multiply that by the x minus 7. At this point, it's just a FOIL or a distributive property, giving us x cubed minus 7x squared plus 9x minus 63. So that is the polynomial that has the three answers of 3i, negative 3i, and positive 7. Suppose I told you that a polynomial has the degree of 5 and that the zeros are 3, 2 plus I, and negative 5i. Think of how many zeros you're missing. If we have the degree of 5 and you're given 3 of the zeros, we're missing 2. Those missing zeros can easily be found because complex and irrational answers come in conjugate pairs. Knowing that fact, if we're having two more zeros, or the missing zero, since we have the complex number 2 plus I, the missing zero, or one of the missing zeros, has to be 2 minus I. And since we have negative 5I, its conjugate will be positive 5I. Let's try that one more time before we go on. Let's say that we have a polynomial of degree 7, and that the zeros given are 3 with the multiplicity of 2, 5, or 3 plus the square root of 5, negative 6 minus 4I, and 9. How many zeros are you actually given? We'll count them up. We have 2 here, 3, 4, 5, so we're actually missing 2 zeros. Those missing zeros will come from the fact that complex and irrational numbers answers will always come in conjugate pairs. We see the irrational number 3 plus the square root of 5, so we know its conjugate of 3 minus the square root of 5 must be a missing zero. We see the complex number negative 6 minus 4I, so its conjugate of negative 6 plus 4I must also be a missing answer. Now let's look at something called the rational zeros theorem. The rational zeros theorem helps find all possible rational answers. To find these possible rational answers, you're going to divide the factors of the constant by the factors of the lead coefficient. Let's see how this works. If we're given the function f of x equals 2x cubed plus 4x squared minus x minus 7, to find all possible rational answers, you're going to take the factor of the constant divided by factors of the lead coefficient. In this case, we're going to take the factors of the negative 7, being our constant, and divide by the factors of our lead coefficient, which is going to be 2 in this case. Think of the factors of negative 7. You can have plus or minus 1 and plus or minus 7. The factors of 2 are going to be plus or minus 1 and plus or minus 2. Now, with two numbers on the bottom, we want to take each of the top numbers and divide by the bottom one. 1 divided by 1 will be plus or minus 1. 7 divided by 1 will be plus or minus 7. Finish with the 1 and move to the 2. 1 divided by 2 will be plus or minus 1/2, and 7 divided by 2 is going to be plus or minus 7/2. Taking another example, let's look at the function g of x equals 4x cubed minus 3x plus 12. To find the possible rational answers, you take the factors of the constant divided by the factors of the lead coefficient. So in this case, we're going to need the factors of 12 divided by the factors of 4. List out your factors. 12 is plus or minus 1 times 12, plus or minus 2 times plus or minus 6, plus or minus 3 times plus or minus 4. The factors of 4 are plus or minus 1, plus or minus 2, and plus or minus 4. Since there's 3 numbers on the bottom, take each top number divided by the first number on the bottom, which is 1. 1 divided by 1 is 1. 2 divided by 1 is 2. 3 divided by 1 is 3. 4 divided by 1 is 4. 6 divided by 1 is 6. And 12 divided by 1 is 12. We're finished with the 1. Take each number on the top, now divided by 2. 1 divided by 2 is going to be plus or minus 1/2. 2 divided by 2 is 1. We don't need to rewrite it. It's already on our list. 3 divided by 2 is plus or minus 3/2. 4 divided by 2 is 2. It's already on our list. 6 divided by 2 is 3, which is already on our list. And 12 divided by 2 is 6, which is already on our list. We finish with the 2, and we go to the 4. 1 divided by 4 is plus or minus 1/4. 2 divided by 4 is 1/2, which is already on our list. 3 divided by 4 is plus or minus 3/4. 4 divided by 4 is 1, which is already on our list. 6 divided by 4 is 3/2, already on our list. And 12 divided by 4 is the 3, which is already on our list. Now, to put all these together, if you are asked to factor a polynomial and find all of its possible or all of its solutions, let's look at the example f of x is equal to 3x, or excuse me, is equal to x to the third. Let's go back to that. Plus 3x squared minus 18x minus 40. Well, since the degree is 3, we know that we're going to have and find 3 zeros. So I'm going to leave a blank for those 3 zeros. We're also going to show the polynomial in factored form. If you can't factor from the beginning, the first thing you're going to do is use your rational zeros theorems and come up with all possible rational answers. In doing that, we'll take the factors of negative 40 and divide by the factors of 1, which will be plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 8, plus or minus 10, plus or minus 20, plus or minus 40, all divided by plus or minus 1, which will give us a final list of just those top numbers. These are all the possible rational answers that this function is going to have. Now, all of these cannot be answers because we know since the degree is 3, we're only going to have 3 answers. But this is the best place to start. At this point, you can do your synthetic division to actually see if these are answers. But if you will graph your function and look for your x-intercepts, it will narrow this list down even further. Let me pull up a calculator. Go to your y equals screen and type in the function x raised to the third plus 3 times our x raised to the second power minus 18x minus 40. Now, if you look at that graph and look for the x-intercepts, you can see we have one that looks like it's at negative 5, one at negative 2, and one at positive 4. So, negative 5, negative 2, or positive 4 are going to be the best places to start since those are also on our possible rational answer list. Set up for your synthetic division using the coefficients of your original function, which would be 1, 3, negative 18, and negative 40, and choose one of the x-intercepts to start with. Let's start with the negative 5. Perform that synthetic division, drop your first number down, multiply and add, multiply and add, multiply and add. We're looking for a 0 remainder, which we have. Therefore, the first answer to this is going to be negative 5. If the first answer or 0 is negative 5, that means the first factor has to be x plus 5. Now, your last two answers can always be found by performing the quadratic formula. If you have a program, punch in A is 1, B is negative 2, C is negative 8, and your calculator will spit out the the last two answers of 4 and negative 2, or that one will actually work by factoring. If 4 is an answer, that means x minus 4 is the factor, or if negative 2 is the answer, that means x plus 2 is our factor. These will always go easier if you can factor from the beginning. Let's look at one that we could actually factor from the beginning. If we look at g of x is equal to x cubed minus x squared plus 3x minus 3. We realize that we are looking for 3 zeros. You're also going to be asked to see this in factored form. So underneath, I'm going to write my factored form. Now, if we set this equal to 0 and try to factor it, we can actually factor this one by grouping. If you'll look at the first two terms, they have an x squared in common. If we pull out an x squared, we're left with x minus 1. The last two terms have a positive 3 in common. If we factor out the positive 3, we're left with x minus 1. Notice both terms now have a common factor of x minus 1, so we can pull out the x minus 1 and be left with x squared plus 3. Setting each piece equal to 0, x minus 1 equals 0, and x squared plus 3 equals 0, we're going to solve both pieces. The first piece is going to be x equals a positive 1, which means our factor was x minus 1. Let me erase that. For the x squared plus 3 equals 0, you can either use your quadratic formula or solve this piece. If x squared equals negative 3, x is going to equal plus or minus the square root of negative 3, which is x equals plus or minus I root 3. So one answer is going to be I root 3, and the last answer is going to be negative I root 3. If I root 3 is a 0, x minus I root 3 is going to be the factor. If negative I root 3 is an answer, x plus I root 3 is going to be your last answer. So it's much easier to solve these by actually factoring first if you're actually able to, rather than going through the whole process of finding the possible rational answers and then the synthetic division. Let's look at one more that has the degree of 4. Let's take the equation k of x is equal to 3x to the 4th power minus 4x to the 3rd power plus x squared plus 6x minus 2. Since our degree is 4, we know that we would be looking for 4 zeros. And then we want to show it in its linear form, factors. So k of x will have 4 different linear factors. This one does not factor from the beginning, so we'll show our possible rational answers. We get this by taking again the factors of the constant divided by factors of the lead coefficient. Factors of negative 2 are plus or minus 1 and 2. Factors of 3 are plus or minus 1 and plus or minus 3. This gives us a complete list of plus or minus 1, plus or minus 2, plus or minus 1/3, and plus or minus 2/3. 8 potential rational answers. To narrow this list down further, let's actually graph this on a calculator. Pull up your calculator, go to your y equals, and type in the function 3x raised to the 4th minus 4x raised to the 3rd forgot my 4, so let me go back there, plus x squared plus 6x minus 2. and look at that graph. You see you have an x-intercept here at the -1, and then here somewhere in between the 0 and the 1. Let's zoom in on that graph by hitting Zoom to Enter. We'll see that graph a little bit closer. -1 is definitely an x-intercept, and this looks like 1/3 rather than 2/3 because it's closer to the 0 than it is at the 1. So we've got -1 and 1/3 would be our best bets from this list. Get ready for the synthetic division. Put our coefficients in descending order, realizing we do not need a placeholder. We have 4th power, 3rd power, 2nd power, 1st power, 0 power. And let's start with the -1. Drop that first number down, multiply and add, multiply and add, multiply and add, multiply and add. Sure enough, -1 is an answer, so x plus 1 is going to be your factor. At this point, you cannot use the quadratic formula. We have, if we were going to fill back in letters, this would be x cubed minus 7x squared plus 8x minus 2. The 3, -7, 8, and -2 is called the depressed equation. When you have a degree of 4, you must find an answer with synthetic division twice. You want to use the depressed equation for your second answer. We're going to work with a fraction of 1/3, dropping our 3 down. 3 times 1/3 is 1, plus -7 is -6, times 1/3 would be -2, plus 8 is going to be a +6, times 1/3 is going to be a +2, with a remainder of 0. So 1/3 will be the 0, and x minus 1/3 will be the factor. At this point, use your quadratic formula to find the last two answers using your a equals 3, your b equals -6, and your c equals 6 for the last two answers of 1 plus I and 1 minus I. Now, if 1 plus I is our answer, then if we're going to take x and subtract that, we're going to have to distribute the negative. So our factor is actually going to be x minus 1 minus I. Our last factor, if we distribute the negative, is going to be x minus 1 plus I. Good luck on this homework.